Welcome to week 2, module 6 of database management system course in IIT Madras online BSc program. In the last week, the week 1, we have taken you through the introductory part of the course, giving you the course outline and basically sensitizing you on the proliferation of database management systems and the wide range of applications and specific need of database in contrast to the power that a file based application can give us. Why would we prefer a database system and when would we prefer a database system? And then in the last 2 modules 4 and 5, we talked about the basic notions of database. Now slowly we will start getting into more specifics, and that will be around the relational database system. So, in this module we will try to understand the attributes, their roles, and talk about the basic mathematical structure of the relational model in terms of schema, instance and keys, and familiarize with very basics of relational query languages. These will be the module components which you can see on the left. So, this is an example of a relation. This I think you have already got quite accustomed to, because you have seen it number of times, particularly this example or its variant. So, it is a table. A relation is nothing but a table which has columns identified by names. So, basically the order of the columns do not again matter, but the names do matter. So, these are called attributes, and then you have, according to the columns, you have multiple rows. Every row is a record or a row or a tuple which has specific values on those attributes. So, this is a basic form of a relation. So, in this, the first thing that comes is we need to know about what is an attribute. So, let us say we are talking about a relation, or we want to keep the information of an entity called student, so that we would be able to have complete information about students. So, we say that these are the different attributes. That is, how do you identify a student, or how do you describe a student? Student is a person. So, a person have millions of attributes, starting from the name and the parent's name and address and hobbies and so on, but certainly when we try to model, we will as attribute choose only those parameters of the entity, or only those parameters of a student which are relevant for our purpose of application, right. That is the business decision. So, naturally the student will have a roll number, that is the first thing required for enrollment, the first and last name, which is very typical. The date of birth will be required. We may have passport number, but every student may not have a passport. Aadhaar number has become mandatory in India. So, the student will have an Aadhaar number, otherwise some of the student benefits may not be available to the student, and the student will always belong to a department, right. This is a very minimum, there will be a lot of other also that will come in. So, these different attributes, each attribute I say is an atomic one. So, it has an atomic type. What type? So, what is a roll number? We take roll number is a alphanumeric string, that it will have integers as well as it will have characters. Now, you could have said that why not just a number, but this will become clear, because through the roll number we want to also do some other hidden communication. First name and last name are naturally string of alphabet. Date of birth is a date type which we take as a atomic type, though it has got 3 components, but those 3 components are represented in a way, whether it is we say MMDDYY, that is month 2 digits, DD is date 2 digits, and YY is year 2 digits. or it could be YYYY MMM DD, 4 digits for year, 3 spaces for month, which could write month as Jan, Feb, Mar, like that, and 2 places for the digit. And so, whatever it is, this is kind of another atomic primitive type used. Passport is a string, say letter followed by 7 digits, which is the standard followed in India. It is nullable. This is important. Nullable means that if a person does not have a passport, how do I enter the data of that student? I cannot. So, what we allow is we may just put a value called null, and what the null means, there is no value, it is not known, right. So, not everything is nullable. You cannot have null as your roll number. You cannot say that I do not know the roll number, not possible, or first name, I do not have a first name, not possible, right. Then you have Adhan number, which all of us know is a 12 digit number, department is a alpha string. So, these in this way every attribute will have certain types, and the important thing is they are atomic, they are indivisible, that you cannot compose first name and last name together into a single attribute, because that is not one alpha string, that is a pair of alpha strings, which is a composite value, right. And null we already have mentioned. Okay. Now, let us go to see more of this. So, again the same. Now, the domain of every attribute, as we have specified, means that if roll number is a alphanumeric string, what does it say? It says that any string composed of the A to Z alphabet and 0 through 9 numerals can be a possible value. So, you can see examples here. The first name is alpha, so the domain is any string that you can form with uppercase and lowercase alpha. The same thing here. In roll number, you could specify that, actually you could further qualify, saying that is alphanumeric with numbers and uppercase alphabet only, but in name you will have that. DOB is, as we say, is primitive. This is a passport number in the format, here is null. So, Jatin Chopra does not have a passport. Here is a Adhan number. The dash demarcations are not part of the actual domain representation. I am still kept that, because otherwise as human being it becomes difficult to read, but in the system this will just be a 12 digit number, and then the name of the department, which is alpha. So, this is exactly given the. So, here for example, in this DOB field, I cannot put a string. I cannot say 27th March 1997, I cannot write this, because the type is date. Similarly, in here, in terms of computer, I cannot write it is CSE 235 like that. So, where 235 may happen to be the course, the code of the department, those kind of things. So, you will have to be compatible with the domain, the values will have to be compatible with the domain. That is a basic property of the attributes. Now, next let us talk about schema and instance. We mentioned it a little earlier. Schema is what the attributes, in relation what the attributes are, and now we know that every attribute has an associated type. So, schema talks only about that. Instance talks about the actual values that the tuples, the rows take according to the schema. So, in the schema is representable mathematically as a relation. Right. I mentioned that you need to know the concept of relation and Cartesian product and all that. So, I hope you have revised. If you not, this is the last time you will have to revise those. So, if there are n attributes, then we say a relation A1 A2 An is a relational schema, because it says that these n attributes are there. So, what does it mean? If I have an instructor with 4 attributes, then this is the relational schema of the instructor. So, now if we say D1, D2, Dn are domains of the respective attributes. So, we said A1 has a domain which is D1. That is, for the attribute A1, given the type, I know what are the universal set of values that can happen. So, any value for the attribute A1 has to come from this D1 set. That is the basic point. Then the relation is a subset of, so R is basically a subset of D1, D2, D1 cross D2 cross Dn, because you are making a n tuple out of n different sets D1 to Dn, right. So, any component of R or a particular row small r belonging to this relation will have values in A1, which is a member of D1, value for A2, which is a member of D2, a value for An, which is a member of Dn, right. That is the basic. So, that R will be an n tuple A1, A2, An written in small case, where each Ai belongs to Di. This is the basic structure of the relational schema. The relational instance or the instance would be the table of actual set of values. So, for example, of relational schema here, I said that instructor is actually a schema of string 5. By string 5, I mean string of length 5, because IDs have to be of 5 length. Cross string, which is the name of the instructor, cross string again, which is the name of the department, cross number plus means one or more numbers in the sequence, which means it is a numerical value, which is the salary. Right. So, that is the basic the correspondence. I think this is easy to understand. So, this is how, now this is the instance that I have is given these columns, and there we are not again talking about their types. So, the columns and their domains have given us a schema, and according to that schema I now have a relational instance, which is a set of tuple set of values that we have. Now, two things are very important to remember always is the order of tuples in the table in the relation is irrelevant. Like 2, 2, 2, 2, 2, Einstein, etc. as the first row, I can put it anywhere else. As long as the total set of rows are same, the two relational instances are same. Right. The order of rows does not matter, because you have to remember, if you recall, a relation is nothing but a set, and a set has no ordering between its member elements. So, every row is a member element of the relation set. So, it has no ordering expectation. At the same time, the other specification of the set says that every element has to be distinct. So, which means that there can be no two rows or tuples which are identical. Every tuple will have to be distinct from every other tuple. So, there will have to be at least one field where this tuple would vary in the value for all other tuples, right. So, this is so let us talk about keys next. Key, the basic concept of the key is there are multiple attributes. Now, not all of them uniquely identify a row, they may, but some, the question is of minimality. Now, naturally, since I cannot have two rows with identical set of values, so clearly all attributes taken together, my every row or every tuple must be unique, identifiable. But the question is, do I really need to know all the values to uniquely identify every row, or can I work with a subset of attributes which can uniquely identify every row? So, we say that let us assume that there is such a subset called K. So, K is a subset of R, the relational schema, which is a set of attributes in the relation. Now, we say K is a super key of R if the values of K are sufficient to identify a unique tuple in each possible relation. Now, given a schema, there can be actually potentially countably infinite number of relational instances. In each one of them, I am saying that if I know the value on k, I will be able to uniquely identify that record. What is the concept? Say, if I say the instructor has an ID, employee ID. So, you say if I know the ID, naturally two employees cannot have an identical ID. They can have identical name, they can have identical department, they can have identical designation, they can have identical salary, they can have so on and so forth, but they cannot have identical employee code. Two students cannot have identical roll number, two Indians cannot have identical other number, and so on and so forth, right. So, I can say that ID is a super key of instructor, but anything which is bigger than ID, say ID and name, will also be a super key, right. So, that is the question, that is the reason you call this is a super key, because you can say that all attributes are also a key, because they uniquely identify every row, but they are a key, but they are not formally called a key, they will be called a super key unless we can prove that there is no subset smaller than this which can also serve that purpose. So, we say that a super key is a candidate key if k is minimal. What is minimality? Minimality means that k is a candidate key and no subset of k is a super key. K is a super key and no subset of k is a super key, then we will say it is a minimal set or it is a candidate key. So, both ID and ID name are super keys. Of that, ID name pair is just a super key, it is not a candidate key. Why? Because there is a subset containing just ID which is also a super key. So, it is not minimal. So, ID and name is a super key, but ID, the set containing ID, is a candidate key because there is no subset, because the subset of a single element will be obviously empty, that is trivially true, but formally saying there is no subset of the set containing ID which can be a super key of this relation. So, we will say this is a candidate key. Now, it is not necessary that I will have only one candidate key, I may have multiple candidate keys. I will not use all of them, I cannot, because it does not make sense. So, of the candidate keys, I will choose one to be the primary key, and that is what we will use as a key. And in the next slide, I will give you some glimpse of if there are multiple candidate keys, what is could be the factors to choose a particular one as a primary key. Besides that, there could be surrogate or synthetic key. In many cases, that you actually the data here, what is happening? You are saying that the data itself is unique. So, if the data itself may not be unique, for example, I am making an order on Big Bazaar. So, I can make multiple orders. I can make multiple orders of the same item. I can make multiple orders of the same item on the same quantity. I can make multiple orders of the same item of the same quantity on the same day, and so on. So, just looking at the data, it may not be possible or easy to uniquify them, but the orders are different. They are not the same order, they cannot be treated as the same order. They may have the same set of items, same quantity of items, same price, they may have been ordered by the same person, they are going to the same address, everything remaining same, they are different orders. So, what do you do? So, you synthetically generate a key, that is the order number. Order number is not there in the nature, you synthetically generated that, and those synthetically generated data which are done at the time of transaction only are known as surrogate key. Now, you will ask that well, if I am saying it like this, then why not you say that employee ID or roll number is also surrogate? Well, one way they are, but they are not. in the sense that if you think about the order number has a life only for that order, and as long as the order is served. Beyond that, you are not going to do anything with that order. So, in the collection of orders, it will remain uniquely identified, but the basic life cycle of an order is limited. It is initiated, it is transacted, paid, delivered, closed, and after that you do not expect any changes to happen. So, that is an entity which has a very short lived time, which kind of relates to just a meta transaction. Meta transaction in the sense that the set of transactions that are required to complete an order, starting from the initiation to the delivery and closure. In contrast, the student or the instructor has a permanency in the system. The roll number remains valid not for one transaction or one meta transaction. It remains valid as long as the person is there. So, in a way, roll number or ID are also synthetically created, but they uniquely identify a unique entity in the world, whereas an order number is synthetically created to uniquify an otherwise indistinguishable entity like an order. That is the difference. So, order number becomes a surrogate key or a synthetic key. Okay. Now, example. So, coming to example here is the student, these attributes. So, what is a super key? Roll number is a super key, roll number, and DOB of course is a super key. DOB by itself will not be a super key. So, what are the candidate keys? These are candidate keys of course. Roll number. Now, passport number, you will ask why not passport number? Passport number is not a candidate key because it is not a super key, because it is nullable, which means that it is optional. So, some students may not have a passport number. So, obviously, I cannot use passport number. If it is mandated that everyone will have a passport number, like every traveler on a flight, on an international flight can be uniquely identified also by their passport number, because they must have one, but this is not the case here. So, passport cannot be used, it is nullable. We can have roll number, we can have first name last name pair, and we can have other number. Of that again, so these are the candidate keys. So, we will have to make a choice for the primary key. So, how do I make that choice? I said that choice has to have additional design criteria. The one criteria here is if I take the first name last name and say that this is a candidate key and want to make it a primary key, then it becomes evident that I cannot have two students with identical name. Right? I have tried to look for Parthapratim Das in Google, even in Google Scholar, forget about the entire Google, just in Google Scholar probably has 18 Parthapratim Das. So, you can say that by first name and last name, it is not proper to identify students, because you will soon get into difficulties. So, this gets ruled out. So, the choice remains between roll number and other number. Other number you can obviously use, because other number is again like a ID which has been created for your entire lifetime. But between the roll number and other number, in this application we will prefer to use roll number, because let us say, and this specific example is certainly the way IIT Kharagpur does it, other academic institutions will do something similar. So, this is a sample roll number of one of my students. Now, you have to read this in this format 14-CS-92-P-01. So, what does that mean? The 14 stands for year of admission, CS stands for the department code, 92 stands for the category of student, whether is a doctoral student, whether is a master's student, whether is a master's by research student, is a undergraduate student, is a BSc program student, MSc program student, has different category roles. Then this letter says what is the type of admission. Is the person a regular student in undergraduate, or the person or the student is actually getting some stipend from the institute, or the person is actually working in the institute, or the person is working in a project in the institute, and so on. Gives you a lot of those information. And finally, given all this being same, the last 2 digits are for serial number. This is assumed that in one category there will not be more than 100, more than 99 people of that. So, what happens is two things. One is it well, the Aadhaar number could also serve the purpose, but here in terms of making the roll number as a primary key, we are doing some shorthand encoding. So, all of these are parameters or are attributes of the person. So, we could blow this up and keep them into separate components. Instead of doing that, these have been compacted and encoded, because very often you do not need to know these attributes separately. So, if you do, then you can always do a small algorithm to recover them. So, this kind of we are doing a trick where actually the key has a composition in notion. Semantically it is composite, but syntactically it is a atomic value, an alphanumeric string. So, this composite idea of these 1, 2, 3, 4, 5, 6 different things, I am sorry, 5 different things have been put together to create a key which is unique and which tells you lot more than just the uniqueness. If you use Aadhaar, you will not have this advantage. So, these are some of the additional considerations by which the first name, last name and the Aadhaar number are not considered to be primary key from the candidate key, and the roll number is. So, in every type of system you may have these kinds of considerations to decide on the key. So, these are the different. So, those candidate keys which are not primary are called secondary or alternate key. A simple key is a single attribute like Aadhaar number or roll number. Composite keys which has more than one component, first name, last name, and based on that I have just shown a table here of possible values or a relational instance that you could have. There is also a concept of a foreign key. A foreign key is, and we will slowly understand this more, is when a particular attribute is a key in a different table. So, you have students table, you have to just look here. You have students table which has roll number as the key. You have the courses table where the course number is the key, and you have an enrollment table which relates the student and the course, which student is in which course. Right? So, for the students table, roll number is used as a key, part of key in another table. So, this is what is known as a foreign key. So, somebody somewhere else I am a key. So, it is very, very important. Now, incidentally it is also a primary key in students, but it may always not be the case. Something which is not a key in a relation could be a foreign key for some other relation. So, this is I will not go through in steps. This is just a little bit of more detailed schema design for a university database that I have given here, and I will leave it to you to study and practice and understand, and if you have questions to raise it in the forum, so that we will discuss, but this is a part of a exercise that you have to do. Now, before we close, I will like to just mention that what are the relational query languages, because we have talked about the basic schema and keys and all. So, how do we finally do the query? So, there are basically 2 ways that we can do a programming. One is called procedural, which tells you how you find a value. Most of the programs you write in C, C++, Java, Python, they are all procedural. And the other is declarative, where you do not say what how you find the answer, but you say what you want as an answer. This example will help. Think about finding the square root of a number n, and this is one way. This is a very standard known algorithm for that. You guess something which is close to the square root of n, and then keep on iterating by doing refinements and checking the deviation of values, and when the deviation becomes low, you know you have got the square root. This whole set of steps, if you see, tells you how to get to the square root, but it does not tell you that this is the square root. You have to come to some external mathematics to prove that, well, this is a square root. If you do this, you will get the square root. So, what is not known, but how is known? How I will do the computation is known. This is procedural. Instead, if I could have a language, and there are languages like this, where I just say that I want, given n, I want to find an m such that m square is equal to n, then it is declarative, because I am saying what I want, not how I can get it. Right. So, this is the basic difference, and in terms of that we will see that it is the declarative style which is useful for relational query, and there are three models I have already talked of: relational algebra, relational tuple calculus, and relational domain calculus, and also remember that they are not Turing complete. So, with this we come to the close of this module, where we have got started in the relational model and discussed about the basic notions. We will continue this in the next module. Thank you for your attention, and see you again in module 7.